Hi everyone, I'm Oren. I'm a software engineer here in Helios. Today I'd like to show you how I use our application that leverages OpenTelemetry in order to do bottleneck analysis in distributed applications. So here we have our Sandbox application. It's a demo application that we use to actually show the capabilities of OpenTelemetries for distributed applications. It's actually a simplified money transferring system. It consists of several services, each with its own implementation, different language. It consists some calls to databases, to third-party APIs. Generally, it's actually a quite modern, basic application. And what I want to show you is how in the recent days we've actually solved an issue with identifying a bottleneck in this application. Okay, so here we can see the UI of Helios that shows the actual sandbox. As I said, here are the services, and I'm now actually filtering the API service. The API service lists several incoming API calls. The one we'll look into is the deposit call. And this deposit call has its traces. Okay, every graph here shows the trace. If I click on this specific trace, then we'll see a specific instance describing a call made to the API service. This is the deposit API call. Okay, this API actually involves many services within the application. So as you can see, we're starting off with the API service, the user service is involved, then there's an account service, financial service, payment service, etc. And actually you can see that the whole process of actually handling the request is caught within this trace. This is the OpenTelemetry trace, and it actually shows how the data flows around, what services are involved, what databases are involved. For example, we have the Ruby service here, the payment service, we have DynamoDB for the account service being used, we have email sent via SES. So this describes the general deposit flow that we have in our system. And this was working rather well in the last couple of weeks. Let's see, for example, if I filter, let's see here, in the last week, if I'll take one of the deposit trace, I want to look at the performance of this operation. So here we can toggle the duration for each span in the system. And as you can see, nothing special. This was running rather okay. We also can show within the Helios Sandbox we have the widgets showing like the aggregation of the performance, and the vast majority of calls was actually working rather quickly for this specific API. Okay, and then in the last couple of days, if I'm looking at the trace from earlier today, we started having issues with performance, and we didn't actually know what was causing the performance issue. So actually this is a trace from today, and as you can see, if I'm toggling the duration, you can see that the duration for this specific branch within the trace showing the call to financial service is taking quite a long time, almost 5 seconds to handle a call to the exchange rate. Okay, so what we're doing actually in the deposit flow, part of the call, if I click on the span here, the system shows me that there's an underlying calls to the financial service, which is trying to actually calculate the exchange rate for some kind of amount in currency. And this specific call took rather long time. Okay, this is almost 5 seconds. If I look at a specific call from a different trace, let's see here, for example, so this one from a few days back took much less. Okay, so this specific issue started a few days ago, and we weren't sure what exactly was happening, but this specific view showed us rather quickly that the actual root cause for the entire trace taking too long, I mean the actual call to deposit was taking too long to handle, and the specific call made a call to Kafka within so this specific API call was involving Kafka, and inside Kafka we're seeing bad performance. So this specific API call is actually calling the financial service, which takes too long to report back with an answer. Well, this was quite a good start, because usually within a distributed application you're making an API call and it's suddenly taking longer and you have no idea what's going on. I mean, there's so many services involved, there's so many moving parts that you don't know where to start. I mean, we usually go and look in logs and try to understand what's taking so long, but just taking the specific trace and visualizing it was so easy to pinpoint the issue within the financial service and then go and see within the service what was taking so long. Okay, so basically there's no database involved, as you can see. For example, other services are actually making calls to third-party APIs or databases, but this specific flow was actually only calculating the exchange rate and reporting it back. So it's not exactly obvious what took so long. Okay, so I then went into the code directly there, because I knew the issue was there, and I tried to actually identify what could be the reason within the code that's causing it. Okay, so it wasn't clear. What I've decided to do is actually add what we call a custom span. Okay, I wrapped a bunch of code with a custom span. Okay, it means that I'm actually reporting a specific part of the application separately. And this is the actual part that was verifying the currency being sent. Okay, if here we have an API call that actually sends an amount in currency, we were verifying the currency before we were supplying the actual rate for the currency. So I added this custom span, and when I looked into the duration, I've noticed that this is actually the part that's actually taking so long. Okay, and this was changed rather recently. So by adding the custom span and identifying the part in the application that was taking so long, I was able to quickly identify the bottleneck within the system. This is something that usually takes much longer. I mean, if I have to look into logs and then I have to, play the whole thing again and again and try to understand where the system takes so long to respond. Here I was able to quickly identify it within the financial service and then wrap the code that I was suspecting was a problem and identify that this is actually the problem. Okay, then it took quite 10 or 15 minutes later to understand the bug, and once it was resolved, I rerun the service again. Here I'm looking at a trace from like 10-15 minutes later, and here I still have the custom span for currency, but now it's taking much less. Okay, so this was rather straightforward approach. I mean, I used the trace. It was easily understandable to see that the actual majority of the time we spent, if I look at the original problematic trace, was within this part of the financial service and not anywhere else. And then once I identified the problematic code, I was able to wrap it with my own custom span and then actually fix the issue and see that the issue was resolved. Okay, by running it again. And that's basically it. I'll put a link in the description. One is for our Sandbox application. It's free of charge. You can play with the application, see what kind of data is available on the traces, what you can do with the traces. I mean, it's not only bottleneck analysis, you can do much more. So that's it, and thank you.